Hello guys. Today we will learn how to draw the timeline for a D-Flip-Flop with a clock, a reset signal, and another input that is determined by a set of some logic gates. First we will be looking at this preemptive logic circuit that we can see how the output reacts to the inputs directly if this circuit is not controlled by any clock signal. In this case, I wanted you to see how if I'm changing any of the 2 or 3 branches parameters, the output will directly react to the changes in the inputs or in the intermediate signals. Now we look at the D-Flip-Flop circuit. As you see, we need to keep the reset signal on in this case. The reason we keep it on so it can pass through the input signal that we call in1 in this example. No matter what we do with in1, the output will not reflect the input signal. So we have to keep the reset signal on all the time for the D-Flip-Flop to have it functional. Now, when we turn the reset signal on, every time we change the input signal in1, the output will reflect exactly what is showing in the input signal. The next circuit we look at is the clock circuit. And as you see, I've added some delay signal here so we can actually see what it's doing when we detect the positive edge of the clock signal. The positive edge of the clock signal is detected, and that is when we start the execution of the circuit that we have controlled by a clock. Okay, now we get to a clocked D-Flip-Flop circuit. With the clock, nothing will happen unless we detect a positive edge of the clock. If you see, no matter what we do to the reset signal, to the input signal, the clock is the one that allows the circuit to recognize the input or to start calculating the input. So if we say the input is on, the reset is on, the output can only be on when we see a positive edge or rising edge of the clock. Let's turn it off. We cannot turn it off unless we see another rising edge of the clock. The output cannot be modified unless we see the positive edge of the clock. Now, to understand a little bit of how the dynamics work for the D-Flip-Flop circuit, I fed the negated output signal as an input to the D-Flip-Flop circuit, and as you see here, we have a negative Q or negated Q fed to the circuit. This will change as we flip the clock, and it will only change when we detect the rising edge of the clock, and it will not care whatever happens in between those times, and by those times we mean the positive edge to the positive edge of the clock. Regardless what happens in between them, we only see output changes when we trigger the positive edge of the clock. Here's another change to the circuit of the D-Flip-Flop, where we have changed the clock signal to a half hertz or 2 seconds period clock signal. And this will allow us to see dynamically what happens when we feed the negated output to the input side of the D-Flip-Flop, you can see that the output is actually changing from 0 to 1, or it is changing direction at every rising edge of the clock itself. At this point, we will combine the D-Flip-Flop, the clock, and the logic circuit to see what happens when we combine all of them, and how the D-Flip-Flop will react, and how the logic circuit will affect the D-Flip-Flop with the clock or without the clock. Here you can see whatever we change, and no matter what we change in the logic circuit as an input to the D-Flip-Flop, nothing will happen to the output until we see the positive edge of the clock. That is the only time that the D-Flip-Flop will react to the inputs. The idea is, at this rising edge, we need to determine what is the present, and we need to decide what is the future state going to be for the D-Flip-Flop from this point. This point, what we see is the present and the past of the output of all the inputs. Now in this case, what we did is we have changed the N1 signal to use the Q signal. So now we see more dynamically what happens when we trigger the clock, as the Q signal will determine what do we do with the N2 and N3 signals. With this, you will see that without the clock, no matter what we change, nothing happens to the Q. When we change the clock, the Q will impact how we look at the inputs. Now you see, as we use the half hertz clock, you see more dynamically how this circuit works, as we have a feedback coming from the end of the D-Flip-Flop to the front of the input circuit.